Assalamualaikum warahmatullahi wabarakatuh and greetings. I am a representative from Group 1 and I'm going to explain about water reticulation project. Water reticulation is water distribution network that is delivered to the customer. The distribution comes from the pressure created from the supply and delivered to its destination. The volume of water needed is the other factor for planning and designing the system. The water is usually delivered to its destination with the use of pressure and the energy created by the pressure. The objective of this project are to determine the design flow, next to analyze the residual head for the proposed pipe size, and to propose a water supply reservoir and the pipe network. Here are the specifications of pipe used for this project. The diameter of pipe used is 0.3 meter. The material used is HDPE pipe, which is also known as the high-density polyethylene, and the roughness coefficient is 150. There are three types of scenario diagram, which are proposed layout design, peak flow layout design, and firefighting flow design. As you can see, here is the proposed layout design. Now, for water reticulation layout plan, we assume that each hostel has 5 stories and the height of each story is 3.1 meter. Thus, we know that the hostel height is 15.5 meter and the height of cafeteria is 4.3 meter. The reduced level is obtained from getting contour line in AutoCAD. Next, the length of pipe is obtained directly from the AutoCAD. Meanwhile, we assume 300 mm for each diameter of pipe. Now, let's move on to water demand calculation. In order to find the total water demand, we calculated the water demand for hostel and water demand for cafeteria, and then we obtained the total water demand, which is 1,170,400 liters per day. Based on this slide, we can see that the value of peak flow is 2,926,000. Firefighting flow layout design. The fire risk for parcel A is classified in class B and we get 7,776,000 liters per day. Subsequently, the fire flow obtained is 8,946,400 liters per day. Since Q of fire flow is larger than Q of peak flow, we will use fire flow design as our main design for water pipe layout. Next is water tank design. We can calculate the total water supply from reservoir by adding the value of parcel A, M, and N, and then we get 26,839,200 liters per day. And the total daily demand is same with Q reservoir, but it is in meter square unit. Let's take a look at the proposed design. The structural height is 25 meter. The reservoir area and depth is 2,970 meters square and 10 meter respectively. And the reservoir volume is 29,750 meter cube. Reservoir volume is higher than total daily demand, so proposed design for reservoir is accepted. The proposed reservoir tank will be made from steel fused with glass. Steel is strong and have high flexibility while glass has high corrosion resistance. For water reticulation calculation, we use Hardy-Cross method. First, we assume flow direction is in anti-clockwise in both loops. Here is the formula that we use. Now, let's move on to the calculation of HBM. We already tabulate all the data we get in this table. In order to stop the iteration, the total head loss must be equal to 0. If the total head loss is not equal to 0, a correction must be applied before proceed with next iteration. In our case, we use the iteration 4 times before we finally obtain 0 in head loss. For residual head layout, we use two methods in order to identify whether our assumption is correct or not. The first method must be exceed 7.6 meter and the second method, the residual head must be positive. We can conclude that both method is okay. Hence, our design assumption is correct and we don't have to change the diameter of pipe. So that's all from us. Thank you for watching.